Welcome everybody to TechEd. This year my name is Otti Topaz and I'm the VP AI Products at SAP Emarsys. I'll be joined today by my colleague Levi.
Thank you, Otti, and welcome everyone. I'm responsible for data science and data engineering at Emarsys, and I'm really excited to share a couple of thoughts on the data infrastructure we are having, and also to share some more details on a couple of AI use cases we have. So go ahead, Otti, thanks.
Thank you, Levi. So as Levi mentioned, we'll talk about the customer engagement platform that we have here at SAP Emarsys, which is fueled by AI. So I will be rather quick, talk about the high-level overview of how our platform is built and how AI is built into the platform to provide you with true one-to-one personalization. I will then hand over to Levi, who will talk about the more technical aspects of our AI under the hood. Let's begin. What we can see here, first of all, is where does SAP Emarsys belong in the general SAP vision? And of course, we're part of the intelligence suite, part of the CX family of products, and more precisely, we are part of the marketing building block. Of course, we are already integrated and integrating into commerce, sales, services, and everything else, and we are building on the SAP customer data platform, which is obviously key to our AI offering, or to any AI offering for that matter. So how is our platform built is what you can see on the screen right now. We have various channels. We have reporting analytics on top of it. We have our Omnichannel automation. We have a personalization service, which is channel agnostic, a loyalty platform, and of course our own data platform, which is now being fed by the SAP CDP. We have industry-specific solutions built from strategies and use cases dedicated to the industry, and of course our AI platform, which is what I'm about to talk, that is being feeding actually every other solution that you see on the screen right now. And why are we even bothering? And what you see on the screen right now is that's because personalization drives measurable outcomes, and true one-to-one personalization, we believe, is making a difference. What you see on the left of the screen is the engagement uplift of campaigns that are using personalization versus campaigns that does not use personalization. We have around 40% uplift in both open and click rates for those campaigns. And furthermore, on the right, you see that purchases over time, we have uplift of over 20% for customers that are using our AI solutions versus customers that do not. So this is very, very, very significant for our customers, and that's why we believe in what we do so much. Another example is our send time optimization, and those are again, engagement improvement over time using our send time optimization. So our AI decides when to send the message. And I think the most important thing on this slide is to show that we have over 1% conversion uplift. And this is achieved by only one click of a button on the interface. And we're very, very proud of this solution. What I'll show you next is the way we approach AI and the way we look at it. And the first thing we do is helping our customers build their audiences. So we can provide predictions into the buying probability for customers, for leads, and how much revenue those contacts will provide to the business. And by doing that, the customer, the marketer, can actually build the right audience. Once the right audience is built, then we are helping, our AI is helping with the right message to this audience. And this is the what part of this slide. We're looking at product recommendations, we're looking at content recommendations, we're looking at incentives. We just launched a visual similarity-based recommendations. So once you have the audience, you have the right content, you want to know when to send it. And this is what I just showed you with the send time optimization. So the right timing. And of course, the last thing is where, in which channel should we communicate with the customer at that given time, whether it's their mobile app, maybe the website, or sending them an email. This is very high level, very quick introduction to our AI offering. And at this point, I would like to pass it on to Levi, that will talk more about under the hood and the way our machine learning actually works. Over to you, Levi.
Okay, thank you, Adi. Actually, as I mentioned, first I would like to talk a bit about our data infrastructure, because as you might already realize that when it comes to any kind of AI solutions or project, the 90% of the work that is rather data engineering than the AI part of that. So basically, you can see a couple of slides here or charts, and all these things, it is not visible by the marketer. So all these things is for us. We have applied AI in many parts under the hood in our product, and these are just a couple of examples that you can see on this screen. When it comes to the infrastructure we have, it is a kind of snapshot that you see right now. We have been working on to move the whole infrastructure into the cloud, and the snapshot is 1 year old, I guess. So we are moving from the internal infrastructure into the cloud, and the majority of our infrastructure is already being there. The point here and the main reason why I show you this slide is that 1 year ago we already have had around 2 petabytes of data, and it is a crucial part, or it is a really important aspect when it comes to scalability, how we can and how we should scale our solutions, not only the AI solutions. Basically, the concept how we are moved into the cloud is that you can see on the screen. So it is a really basic and simplified version of that. So there are different events happening on the coming from the users, and basically we load any kind of data on a real-time way into Google PubSub. That is the very first step, or the entrance into the data infrastructure. Then we're applying some kind of transformation on the data flows and on a real-time way. And the concept is the next. So we immediately load that data back into PubSub topics to make it sure that it can be consumed by other products and services on a real-time way later on. The second type of data processing or data storing, that is, we put down every piece of data into Google BigQuery for later analytical purposes and for machine learning training and many other purposes. And the third one is when we store the data in cloud Bigtable and similar solutions to be able to answer or serve the data with a very low latency on user level. But you also can see on this slide on the right part that is about the AI piece. So basically how we are training the AI models that is running on the top of Google BigQuery. It loads the data in Kubernetes, and then we put the data back into Google BigQuery, but later on I'm going to share more details on that. So how you should imagine if I changed structure a bit. So actually on the middle of this screen you can see the data infrastructure, which could have any kind of name like data lake or whatever, which is important that you can see on the bottom right place of this slide, which is there is a computer or whatever. So this is a device, a user device, and a lot of different user behavior data coming into this system on a real-time way. This is the so-called behavior data. So it can be email behavior data if someone is opening an email or visiting a website, or they do something with their mobile phones, and so on and so forth. What is important is that if anyone is visiting a website from the client end users on the globe, then it is going to be there in this system within a couple of seconds, so it can be it can be available for further processing and so. But that is not the only way how we consume data or load data into the system, because there are many different other integrations with client backend systems and some other ways of how we load the data. So it is not only that we collect data from the user devices, and that part you can see on the top. So there is a flexible onboarding and data integration on the top. And what is happening here is that we are collecting a lot of different data sources, load that into a common data infrastructure. And the main purpose of doing so is to make it available for any other products we have. Like you can see on the bottom, there is the automation. Under that, there is personalization and segmentation and many other products. And the goal here is to let the marketer put together marketing automations. And obviously their goal is to have a kind of impact for the behavior data of the end users. So we let them do it by one-on-one personalization, and then send all these marketing messages out through different channels. And if you think about it, is a kind of circumambulation of the data of what is happening here. So on one hand, behavior data is continuously coming into the system. On the other hand, by the marketer-defined automations and personalizations and other actions, we send messages to the end user, and this way we and also the marketer would like to create an impact for the user behavior. So this is the circumambulation here. And on the left side, you can see a couple of examples of what kind of other data transformation happening in the system. So there is smart insight. So for example, how we can gain further insights based on the data and gain knowledge and provide it to the marketer so they can make better decisions. And so there is the AI part and the product recommendation and many others. And it is really important from this sense. AI is nothing else, just a kind of data transformation. And the only reason why one could say it is AI, because it is connected to an execution, and it works end to end in either a word. And this way, it is doing something. It could have an impact on the user behavior on an automated way. And my next example is more about that, how you can or how you should imagine that. So my first example is the send time optimization. As Eddie mentioned, it is a really nice or cool feature because it is only a switch on the UI. And as soon as the marketer turns it on, behind the scenes, what this solution is doing for them is it is optimizing the email sending times for the next 24 hours at the moment. So it sounds really basic, but behind the scenes there is a Bayesian learning algorithm which is optimizing the sending time on user level. And what you can see here, that is basically the infrastructure. So it starts from the suite. So we call the core part of our system as suite. So there is a core which is arriving into the email scheduler service to schedule the emails by an automation. And actually, at this point, it doesn't matter if that is an AI or just some kind of automation. I mean, from the marketer perspective, you will see later on the most important thing is to have the results and prove it for them. So there is the next service, which is the AI experiment service. And the main role of this service is that it is calculating the sending times on user level based on this Bayesian learning. And later on, I will cover it a bit more detail, but we are not only having one algorithm which is running behind the scenes. We are running multiple algorithm versions, so we can test them against each other. And without interrupting the marketers, we can switch between them. So just this is the way how we can optimize it further. And obviously, as I mentioned, AI is just a kind of data transformation. So we put back that data into BigQuery, and based on that, the emails can be scheduled. And this is the way how this end-to-end use case is happening. My next example on this algorithm is that, so as you might see on the previous slide, it is a complex infrastructure. There are a lot of data transformation here and there. There are many services which participate in this complex system, but eventually there is only a couple of lines of code which does the most important part, which is in this case the Bayesian learning. So in reality, the algorithm itself, that is, we implemented that in BigQuery user-defined function, which is a very similar language to JavaScript. And the most important part of that, actually it is just 70 lines, I guess. And I just put here, I don't know, 20 lines. But the most important part you can see in the middle, which is calculating some beta distributions for the different slots on user level. And based on that, we can define when to send the next email message on user level. So it was, I don't know, 70 lines in Google in this language. But on our language, it was, I don't know, 1 or 2 lines. And the whole infrastructure is made up for this purpose, just to run those 1 lines or 2 lines or 70 lines in this language. And eventually the goal is to, for this algorithm, is to improve the open rate of the email campaigns. This is what you can see here. I mean, actually, this is the uplift of the open rate, and these numbers are aggregated over time from all the accounts or clients who are using this feature. So, with other words, the expected uplift by this feature, it is more than 3%. In terms of open rate, but obviously we're not only measuring the open rate as you have seen on the slides from Otti. We're also measuring other KPIs like the click-through rate and the conversion rate and so on. So on this slide, what I put here is that the blue dots, the big ones, those dots are coming from the, let's say, the baseline learning algorithm we have. But on the back end, we not only run that, but as I mentioned, we are having new algorithm versions, which are rolled out for I guess randomly selected 100 clients, and for just the 5% of their end users. But so the marketer won't realize anything of it. But on the back end, we can measure if those algorithms are better than the, let's say, legacy one. And as you might have seen here, one of the new algorithm versions, which is the activity-based priors, it is just an arbitrary name, we figured it out. So it is almost doubling the results in terms of click rates, but we also having some amazing results in the other KPIs as well. The most important thing is that from the marketer perspective, they don't see anything about it. They don't see the whole system, how it is working. They don't see these detailed measurement pages and so on. They just see a click of a button, and there is a really basic measurement next to it, which is just one number, which is telling the business KPI and how big uplift was there. And that is the point when it comes to adoption. But later on, I came back to this question. So our goal at Emarsys is to make any kind of AI solution as simple as we could. So the marketers don't have to deal with the complexity and how it is working. They just can measure the uplift that was generated by a specific product. Okay, the next topic I would like to cover today is how our AI platform is built in. So it is another really interesting feature. From the marketer perspective, it is just a couple of segments on the UI. So right now, I guess we are having around 10 or 15 AI scores or so-called predictions. And on the top of each and every AI score, we are having 3 segments. One as like if that is a prediction for making a purchase in the next 30 days, for example. And there's a segment on the top of that, who are the ones who is going to buy something in the next 30 days? Who are the ones who are likely to churn in the next 30 days? And who are the ones who are likely to remain inactive? And this is the thing, so they don't really have to understand AI. And I guess it is really important because usually they don't have the resources, the understanding, the knowledge how it is working. And in reality, in the majority of the cases, it is not necessary to have it at all. So when it comes to the infrastructure, as I mentioned, all the data lives in Google BigQuery. And the model training is a Kubernetes cluster, and the code is written in Python that reads the data from Google BigQuery, do the backtesting and eventually, or as a result, it is going to store the trained predictive model and put that into Google Cloud Storage. And by that, we can calculate the predictions on user level. And we are doing that on demand as the campaign has to be sent out. Then we just run the AI scores or the predictions. It is done within a couple of seconds, or in certain cases in a couple of minutes. So it is really great for the batch use cases. And then we wrote down the AI scores into Google BigQuery again. And on the top of that, there is this labeling you can see there. That is how we are splitting up or transforming the scores into 3 segments. And we write the data again back to Google BigQuery and make it available for segmentation or for any other products that might use it. But when it comes to the backend. So it is a huge backend, as I mentioned. It is really easy to add new scores and test it on hundreds of accounts, for example. So we are having a really broad monitoring system around it. So this is an example of how we are measuring and monitoring the performance of all the different AI scores and segments. So we have to make sure it is still working. And this page lists all the different AI scores for all the accounts, and we can just understand if those are still working or if there is any issue. When it comes to optimization, so this screen is talking about a specific metric, which is the AUC metric in this case, because this is a binary prediction. It is again the buying probability prediction, how likely someone is going to buy something in the next 30 days. So what you can see here is the data points are coming from all the accounts who are having this feature enabled, and all the backtext back in the time. And as you can see, as time goes on, the performance of this prediction is increasing. And the main reason behind that is that we are having more and more data available. And actually, there is a gray area there, and that is the interquartile range between 25 and 75% for all the accounts. And the black line is the median value. So that is a typical AUC value for a given client. And in this case, I just selected one client, and that is the gray line here. So in this case, this client has a way better performance compared to the rest or the majority. It usually depends on the available data, or most likely it depends on that. Obviously, we are having way more many other metrics that we can see here, and there are many other ways how we can visualize the performance over time. This is another really important part of this platform, which is about how we can come up with new predictions, new scores. And it is relatively easy to come up with a new idea, for example, to predict who is going to buy a bigger legroom on next to a flight ticket. We can deploy that, I don't know, within a day, and if we're gonna have enough clients, we can test that on hundreds of accounts back in time to see what is the performance of that model. In this case, what I've selected it is the web engagement prediction score. It means how likely someone is going to visit the client website in the next 30 days. And the three predictive models that you can see on this screen is three different versions for the same purpose. And in this case, each dot means the AUC value for a specific account. And based on these charts, we can decide which predictive model performs the better on a global scale. I mean, for the majority of the accounts. And so in this case, it should be the second one, especially because of the first version could be similar to that one. However, it is producing really poor AUC values for a lot of clients, which are insane, and it does not make much sense. So you can imagine if you have the same prediction problem, you can apply, I don't know, logistic regression, neural network, and many other type of techniques. You can change the feature variables and so on and so forth. It is not the job of the marketer. We are dealing with that on scale and choosing the best performing algorithm versions and roll it out for all the clients. My last slide about this platform monitoring is if I select one client data with a specific prediction and with a specific trained model, which is coming from the backtest, which are generated automatically by the system, then I will get a way more detailed charts and metrics about that specific prediction, how it is performing. I assume if you are familiar with the predictive models and how to test them, how to understand the performance, and so these charts will be familiar with you. I'm not gonna share more details on that. Maybe the very first one on the top left corner. So that is just a histogram of the scores or predictions on user level. And if you imagine there are two lines, how I split this chart, then it is the way how we come up with the segment. So with other words, let's say if we consider anyone who has less than 10% probability to buy something in the next 30 days, those guys are gonna remain inactive. And that is the segment how we define that. In the middle, between, I don't know, 10% and 60%, we consider everyone as likely to churn. And in the high segment, we're going to consider anyone as active who is above that line. Okay, so the most important takeaway out of this session, I guess, is that in any cases when there is AI involved behind the scenes, that is for me just a kind of end-to-end automation of a specific problem or solution or product. And obviously, it is not easy to put that together on a scalable way, and we have to need to have a lot of different monitoring pages and so on and so forth. But it is, I guess, it is not the work of the marketer to understand how it is working, if as long as we can prove the results there. So that is the end, and I really would like to share this information with you. So there are many other learning opportunities from SAP TechEd, so you can look around this slide and so. And I would like to thank you for your attention. And these are the contact information if you have any further question or thoughts on this, and we are really happy to answer any questions. And again, thank you for your attention.
Woo!